You know what fascinates me most about Neil deGrasse Tyson? It is not his telescope, it is not his television show, it is not even the way he talks, which I must admit is considerably more polished than the way I talk. What fascinates me is that he sat down with a science fiction writer named Andy Weir, and instead of saying, "Nice story, good job," he did what every real scientist should do. He pushed back. He poked. He prodded. He said, "Wait a minute, does this actually work?" And that, ladies and gentlemen, is the most beautiful thing a scientist can do. Not applaud, question. Now, I have been gone for a while, so let me catch up. There's a book, a wonderful, ridiculous, deeply serious book called Project Hail Mary. And in this book, something is eating the sundae. Not a big dramatic explosion, not a war, not a political decision, something microscopic. A tiny single-celled organism, smaller than anything you can see, is slowly consuming the energy of our star. And the interesting question, the Feynman question, is not, "Oh, how scary." The interesting question is, could that actually happen? Is that physics? Is that biology? Is that real? Let me start somewhere strange. Let me start with how the sun actually works, because I think most people, even smart people sitting in rooms like this one, have a picture in their heads that is almost completely wrong. You are sitting there thinking the sun is burning like a fire, like wood in a fireplace. I can see it on your faces. You picture this giant ball of flame, and look, I understand. Fire is bright. Fire is hot. The sun is bright and hot. The analogy feels natural, but it is wrong. Completely, magnificently wrong. And the real answer is so much better. The sun is not burning. The sun is fusing. There is a difference, and that difference is the difference between a candle and a bomb. In burning, you are rearranging electrons. You are taking carbon atoms and oxygen atoms and letting them hold hands in a new configuration, and that releases a little bit of energy. That is chemistry. But in fusion, you are not rearranging electrons. You are smashing the nuclei of atoms together. You are taking hydrogen, the simplest element in the universe, one proton, no neutrons, almost embarrassingly simple, and you are squeezing two of them together so hard that they become helium. And in doing that, you release not a little bit of energy, but an enormous, staggering, almost incomprehensible amount of energy. The mass of what comes out is slightly less than the mass of what went in. That missing mass became energy. Einstein's famous equation, E equals mc squared, and c is the speed of light, which is a very large number, so c squared is an absolutely monstrous number, and even a tiny bit of missing mass produces an explosion of energy that powers a star for billions of years. Now here is the thing, here is where I want you to lean in. That fusion is happening in the core of the sun, not at the surface. The energy produced in the core takes, are you ready for this? It takes approximately 100,000 years to make its way from the center of the sun to its surface. 100,000 years. The photon of light that left the core of the sun when your ancestors were painting animals on cave walls is only now reaching the surface and flying toward your eye, and you thought traffic was bad. So when Andy Weir writes about something that is interfering with solar energy, something that is eating the sun's output, the immediate question I ask, the physicist's question, is where exactly in this system is it interfering? Is it at the surface? Is it in the convective zone? Is it in the photosphere? Because the sun is not one simple thing. It is a layered, stratified, magnificently complicated machine, and where you poke it determines everything about what happens. The organism in the book is called Astrophage, and I love this name. Astro means star, phage means eater, star eater. Now, Neil deGrasse Tyson, when he sits down with Andy Weir, does not simply say, "Interesting idea." He asks the real question, is this scientifically feasible? Could a microscopic organism actually live in or around a star? Could it metabolize stellar energy? And here is where it gets genuinely exciting, because the answer is not a simple yes or no. The answer is, it depends on what you mean by life, and what you mean by metabolize, and what you mean by live. And those are the most interesting kinds of questions, the ones where the answer keeps splitting into more questions. Life, as we know it on Earth, is a chemistry machine. It takes in energy, it processes information, it makes copies of itself. Those are the three things: energy, information, replication. Now, we tend to think life requires liquid water, and for a long time I think we were too conservative about this. We found life in boiling water near hydrothermal vents at the bottom of the ocean. We found life in ice. We found life in acid. We found life in places we were absolutely sure life could not exist. Every time we said nothing could live here, something was already living there, had been living there for millions of years, and was not especially impressed by our certainty. So when Weir proposes a life form that is adapted to exist near a star, to use radiation as its energy source, to essentially perform a kind of biological photosynthesis but on a stellar scale, is that crazy? Let me tell you something. We have organisms on Earth right now called extremophiles. Deinococcus radiodurans, for instance. I love saying that name as a bacterium that can survive radiation levels that would kill a human being 1,000 times over. It has redundant copies of its genome. When radiation shatters its DNA, it pieces it back together like a puzzle. Life figured out how to survive radiation. Life, given enough time and pressure, figures out almost everything. Now, could life evolve to not just survive stellar radiation, but to thrive on it, to use it as fuel? That is a bigger leap. But let me be honest with you, and this is what I admire about what Neil does in that conversation. The question of whether it is impossible is very different from the question of whether it is likely. Physics sets the limits. Biology explores what fits inside those limits. And the limits of physics are wider than most people imagine. Here is a thought experiment. Imagine you are a photon of light leaving the sun's surface. You are traveling at the speed of light, obviously, because you are light, and you have no choice in the matter. You hit the surface of something. What happens? If you hit a solar panel, your energy gets converted to electricity. If you hit a leaf, your energy gets used to split water molecules and combine carbon dioxide into sugar. If you hit Andy Weir's fictional Astrophage, your energy gets used to, well, that is the creative leap. That is where science fiction fills in the gap that science has not yet reached. And the interesting thing, the genuinely interesting thing, is that the gap is real. We do not actually know all the ways energy can be harvested and processed by living systems. We have studied life on one planet for a few hundred years. That is not a lot of data. Now let us talk about Rocky, because this is where the conversation between Neil and Andy gets really good. Rocky is the alien in Project Hail Mary. And I want to describe Rocky to you, because the description is delightful. Rocky is roughly the size and shape of a spider made of rock. Rocky comes from a planet in the 40 Eridani system, a real star that you can point to in the sky. Rocky breathes ammonia. Rocky lives at temperatures that would kill you instantly. Rocky communicates through echolocation. Now, echolocation. Let me stop here. You know what echolocation is? Bats use it. Dolphins use it. You make a sound, it bounces off something, you hear the echo, and from the delay and the characteristics of that echo, you can build a picture of the world around you. It is sonar. It is using sound as a sense, the way we use light. Now here is what is brilliant about what Andy Weir did. He thought, what kind of planet would produce an organism that relies on echolocation rather than vision? And the answer is a planet where light is unreliable. Maybe the atmosphere is thick, maybe the star is dim, maybe there are dense clouds. Whatever the reason, on Rocky's planet, sound turned out to be more useful than light for navigating the world. And so evolution went in that direction. Evolution does not plan. Evolution does not have a committee that decides what features to develop. Evolution just keeps the things that work and discards the things that do not. On Earth, eyes worked, so we have eyes. On Rocky's planet, apparently, echolocation worked better, so Rocky's species developed it. But here is the thing I want to push on, the thing that Neil pushes on in the video. Could an echolocating species develop language? Could it develop mathematics? Could it develop rocket science? Because all of those things require the ability to represent abstract ideas and communicate them to other members of the species. And the specific medium you use to communicate sound, light, chemical signals that matters. It shapes the kind of language you can build. Human language is fundamentally about sequences. We put words in a row, subject, verb, object, one thing, then another, then another. This is because our acoustic system, your ear, my ear, processes sound sequentially, one frequency after another. But what if you had an echolocation system that could process many frequencies simultaneously? What if your language was not a sequence of words, but a chord of sounds? What if you communicated not in sentences, but in something more like chords of music, where multiple pieces of information arrived at the same time and had to be interpreted together? That would be a fundamentally different kind of intelligence, not worse, not better, different. And communicating across that difference, building a shared language from scratch between two species who think in completely different modes, that is the heart of what Project Hail Mary is actually about. I spent a lot of time in my life thinking about communication, not just in physics, but in teaching, because teaching is communication. When I was learning to play bongo drums, and yes, I played bongo drums, this surprises some people. I noticed something. Rhythm is a language. Pattern is a language. You do not need words to communicate structure. You can communicate it through repetition, through variation, through the deliberate violation of expectation. A physicist and a musician are doing the same thing, in a way. They are both trying to find the pattern underneath the apparent chaos and communicate it to someone else. This is what Ryland Grace does in the book. He and Rocky cannot speak each other's language. They cannot even produce each other's sounds. So they invent a language. They start with numbers. And this is exactly right, by the way. This is exactly what Carl Sagan thought about and wrote about in Contact, and what scientists seriously think about when they discuss how to communicate with extraterrestrial intelligence. Mathematics is the universal language. Not because mathematics is human, it is not. It belongs to the universe, but because any intelligence capable of understanding the physical world must have some representation of quantity, of ratio, of pattern. If you can count, you can communicate. You start with 1, 2, 3. You demonstrate you understand addition. You demonstrate you understand multiplication. And from there, slowly, carefully, you build a bridge. What I find beautiful about this idea, and I genuinely find it beautiful, not as a metaphor but as a deep physical truth, is that it suggests intelligence, wherever it arises, is constrained by the same universe. Rocky and Grace have different bodies, different chemistries, different sensory systems, different evolutionary histories, but they share a cosmos. They live under the same laws. F equals ma for both of them. The speed of light is the same constant for both of them. The periodic table has the same elements for both of them. That shared reality is the foundation on which their bridge is built. Now let me tell you about something else in this book that Neil and Andy discuss, and which I find genuinely thought-provoking from a materials science perspective. There is a substance in the novel called xenonite. Rocky and his species build things out of xenonite. It is a material that can withstand the conditions around the astrophage, extreme temperatures, radiation, the chemistry of whatever the astrophage produces as waste products. And Andy Weir made an interesting creative choice. He decided that Rocky's species and the human species are not equally advanced in all areas. In some ways, Rocky is more advanced. In other ways, humans are. Neither species is simply more developed. They've each developed differently according to the pressures of their own worlds and their own histories. Now, this is actually a profound scientific point disguised as a plot decision. We have a tendency, when we imagine alien civilizations, to think of them as simply behind us or ahead of us on some single ladder of progress, less advanced, more advanced. But that is not how evolution works, and it is almost certainly not how technological development works either. Different environmental pressures produce different solutions. The fact that we develop transistors and semiconductor computing does not mean that is the inevitable path to intelligence. It is the path we happen to take, starting from the materials and problems we happen to face. A civilization that faced different problems on a different planet with different resources might develop completely different technologies that look primitive in some ways and incomprehensibly advanced in others, exactly like what Weir describes. I want to take a moment now and talk about something that Neil does in this conversation that I respect enormously. He critiques He finds a specific point in the story's science and he says, here, this does not quite work. This is not quite right. And Andy, to his enormous credit, engages with the critique seriously. He does not get defensive. He explains his reasoning. He acknowledges the limitation. This is what intellectual honesty looks like. This is what the scientific conversation is supposed to look like. In science, a critique is not an attack. A critique is a gift. When I was young, working at Los Alamos, we had something called the seminars. And the most valuable part was not the presentation, it was the questions afterward. Brutal, specific, unsparing questions. You would stand up there and explain your idea, and someone in the audience, someone who had thought about this for 20 years, would raise their hand and point out the exact place where your reasoning broke. And it hurt. It always hurt a little. But it was the most useful thing in the world. Because a wrong idea corrected is better than a wrong idea praised. What Neil deGrasse Tyson does on his show, this confrontation with Andy Weir, is a public version of that seminar. He is not trying to embarrass Weir. He is not trying to say science fiction is bad. He is treating the ideas in the book with enough seriousness to push on them. And that pushing, that friction, is where understanding lives. Let me talk now about one of the most audacious things in the book. The thing that, if I am honest, made me grin when I read about it. The astrophage uses a process that is adjacent to something called the Alderson drive in older science fiction, but Weir gives it a different treatment. The astrophage converts energy into momentum. It literally eats light and uses that energy to accelerate itself. And the key question, the physics question, is whether conservation of momentum allows this. Can a biological system use absorbed electromagnetic energy to generate directed thrust? And the answer, in the real world, is yes. It is called a solar sail. It is called radiation pressure. When photons hit a surface, they transfer momentum. We have measured this. It is tiny. It is real. It is measurable. And in principle, a sufficiently engineered surface or a sufficiently evolved organism could use that radiation pressure to accelerate. Now, the amount of thrust you get from radiation pressure is very small. This is where the book takes its creative leap. Weir posits that the astrophage is extraordinarily efficient at capturing this momentum, far more efficient than any physical system we know. Is that impossible? No. Is it known? No. It sits in that honest territory of we don't know yet, which is my favorite territory in all of science. Here is something I have thought about for decades. What is the difference between impossible and merely not yet understood? This question sounds philosophical, but it is actually deeply practical. In 1900, the idea of a nuclear reactor would have sounded impossible. In 1950, the idea of a pocket-sized device that could access all human knowledge wirelessly would have sounded like magic. The universe is far more inventive than our current understanding. And when I hear someone say something is impossible, I always want to ask, impossible according to which laws? Because the laws we have are not the final laws. They are the best laws we have found so far. And science has a long, proud, embarrassing history of discovering that what we thought were the final laws were actually just the first draft. Now, let me tell you about something that I think is the most important scientific idea embedded in this story, and it is something that does not get discussed enough. When Grace finally understands that Rocky's planet is also dying, that Astrophage threatens the Iridian home system just as it threatens ours, he faces a choice. Help Rocky save his planet, or use Rocky's resources to go home and save Earth. And what the story is really asking, underneath the orbital mechanics and the alien biology and the Xenonite spacecraft, is what is the geometry of intelligence's obligations? We are used to thinking about this in human terms. Do I help the person in front of me or the many people far away? Do I help my country or my species? These are familiar ethical arguments, but Project Hail Mary makes the question cosmic. Do I help my species or do I help intelligence itself? Do I help carbon-based life or do I help any life, wherever it has emerged, whatever it has become? I do not know the answer to that question. I want to be honest with you about that. I have thought about it, and I find it genuinely unresolved. And I think that is appropriate, because the honest answer is that our ethics have not yet caught up to the scale of the universe. We are still, morally speaking, a very young species. We care about the people we know, then the people who look like us, then the people who live near us, then perhaps all humans, and we are still working on that last one. But the universe is asking us to eventually care about something larger, about intelligence, about complexity, about the extraordinary improbability of minds existing at all in a cosmos that mostly does not have them. The physicist in me wants to say something here that might surprise you. Intelligence is a thermodynamic miracle. The universe trends toward disorder, entropy increases, things fall apart. That is the second law of thermodynamics, and it is not a suggestion. It is the most reliable law in all of physics. And yet here we are, here I am, and here you are, and here is Neil deGrasse Tyson on a screen talking to a science fiction writer about organisms that eat stars, and we are understanding each other. We are exchanging information. We are making meaning. In a universe that is constantly dissolving into randomness, intelligence is a pocket of increasing order, maintained against the current, burning energy to stay coherent, to stay aware, to stay curious. That is what the astrophage is disrupting, by the way. Not just the temperature of a planet, not just the life cycle of a star. It is disrupting the conditions that allow pockets of order to exist. It is threatening the thermodynamic miracle. And when you think about it that way, the stakes of the story become cosmic in the truest sense, not dramatic movie cosmic, genuinely, physically cosmic. Neil deGrasse Tyson, for all his polish and his showmanship, does something important in that room with Andy Weir. He models what it looks like to take ideas seriously. He shows that science fiction is not just entertainment. It is a laboratory of thought experiments. It is a way of stress testing our understanding by asking, what if this were true? What would follow? Could it work? And the willingness to ask those questions seriously, to follow them wherever they lead, to say, I don't know when you don't know, and this doesn't work when it doesn't work. That is science. That is the whole game. I spent my career trying to teach people how to think, not what to think. And the distinction matters enormously. What to think is a list of facts. It is useful, it is necessary, but it is finite. How to think is a method. It is a way of approaching any new problem, any new mystery, any new piece of information, and figuring out what is true. And what Neil does in that conversation, and what Andy does in the book, and what I tried to do in every lecture I ever gave, is model that method. Ask the question, follow the evidence, update your beliefs when the evidence demands it, and never ever be more certain than the evidence warrants. There is a moment in the video that I think is quietly wonderful. Andy Weir talks about how he built Rocky's biology around a real exoplanet in the 40 Eridani system. He designed the alien's morphology, its technology, its culture, based on what the physics of that planet would require. Heavy gravity, dense atmosphere, high pressure. And then, after the book was written and published, the planet was found not to exist. The astronomical data changed. The planet that he based Rocky on turned out to be a detection artifact, not a real world. Now, a less secure person would be embarrassed by this, but I find it beautiful, because what it reveals is that Weir was doing exactly the right thing. He was following the science faithfully. He was building from evidence, and the evidence changed, as it always does, as it always should. That is not a failure of the process. That is the process working. The process of science is not about being right the first time. It is about being right eventually through successive approximation, through repeated measurement, through willingness to change your mind. I have been wrong many times. I have been spectacularly, publicly wrong. The weak force, the renormalization, the path integrals in each case. I had to revise my thinking when the data said so. And each revision was a gift, not a punishment. Each revision meant I understood the world better than I did before. Let me close with something that I hope you will think about on your way home tonight. Something that connects all of these threads, the astrophage and Rocky and the echolocation language and the dying stars and the thermodynamic miracle of mind. We live in a universe that is 13.8 billion years old. For most of that time there was nothing alive anywhere. No eyes to see the stars, no minds to wonder about them. The stars burned and expanded and collapsed and exploded and formed new stars and exploded again, and none of it was observed by anyone. And then, on one unremarkable rocky planet orbiting one unremarkable yellow star, something happened. A chemistry experiment in a tidal pool, or a volcanic vent, or a drifting meteor's impact. Something happened and molecules began to replicate. And 4 billion years later, those molecules evolved into creatures with nervous systems complex enough to ask, what is a star? That is astonishing. It is genuinely, purely, physically astonishing. We are how the universe looks at itself. Our eyes are made of atoms forged in dead stars. The calcium in your bones, the iron in your blood, the oxygen you just breathed, and all of it came from the nuclear furnace of stars that lived and died before our sun was born. You are not looking at the universe. You are the universe looking at itself briefly, with curiosity and wonder and the occasional wrong assumption that has to be corrected by someone like Neil deGrasse Tyson. And if there is a Rocky out there, somewhere in the 40 Eridani system or somewhere else entirely, made of different chemistry, breathing different gas, hearing the world rather than seeing it, that Rocky is also the universe looking at itself. Different face, same cosmos. Different language, same mathematics. Different biology, same thermodynamic miracle. The question that Project Hail Mary asks, underneath all the adventure and the science and the friendship, is if we ever meet that Rocky, will we recognize it? Will we have the patience and the humility to try to communicate, even when communication seems impossible? Will we offer help when we could offer harm? I think about this question and I find that I genuinely do not know the answer. I know what I hope the answer is, but I have learned, after a long life of physics and mistakes and revisions, that what I hope and what is true are not always the same thing. And that uncertainty, that honest reckoning with the distance between hope and knowledge, that is not a weakness. That is the beginning of every real question that was ever worth asking. Keep asking. That is all. Just keep asking.